Welcome to Code Along with Alex. I'm Alex, and let's get right back into it. So today we're going to be looking at functions in the Rust by example documentation, and let's just get into it. So I have VS Code open, created a new folder in our Code Along Rust by example repository. So to get started, we'll just create a new cargo project. We're going to call it cargo new. Call it functions. And then let's change into functions. So we'll open this main.rs. And then let's just read a little bit of the blurb that the Rust team has in the functions section. So functions are declared using the function keyword, or the fn keyword. Its arguments are type annotated, just like variables, and if the function returns a value, the return type must be specified after an arrow. Okay, and the arrow is the hyphen right caret sign. As seen here. The final expression in the function will be used as a return value. Alternatively, the return statement can be used to return a value earlier from within the function, even from inside loops or if statements. So let's write fizzbuzz using functions. Cool. So unlike C or C++, there's no restriction on the order of function definitions. So we can define functions, or we can use a function in a certain place and define it elsewhere, and the order doesn't really matter. So let's just add a fizzbuzz2 call. And so we want to do fizzbuzz to 100, and that's going to be our main function body. Next, let's do the fizzbuzz2 function. So we'll do fizzbuzz2, and it takes parameter n as input, and that's of type unsigned integer 32. And so for n in 1 to n inclusive, fizzbuzz n. Okay, cool. So we're invoking this fizzbuzz function. So let's define that next. And I'm missing a closing semicolon. So now we're good to go. Okay. Let's now define that fizzbuzz function. So fn fizzbuzz, and then it'll take parameter n as input, and n is of type u32, unsigned integer 32, and the fizzbuzz function will return the unit type because it doesn't actually return a value. It's just printing out a statement for us. And so we're just going to return the unit type. So if is divisible by, and this is a new function that we're invoking that we haven't defined yet, but we'll do that very soon after we finish the fizzbuzz function body. And so if divisible by n15, then print fizzbuzz. Okay, and then else if is divisible by, and then n3. So if n is divisible by 3, print ln fizz. And then else if is divisible, excuse me, itchy ear, by, and then n5, println macro, buzz, semicolon, goodness. And then finally, or else, println macro, and we just want to return the value n if n is not divisible by 15, 3, or 5. Cool. let us now define our last function, is divisible by. So this will really help put everything together and make our functionized FizzBuzz work like a charm. So let's do our final function statement. Is divisible by, and this will take two input parameters. We'll say left-hand side, and that's an unsigned integer 32, and then right-hand side. That's also an unsigned integer 32, and this function returns a Boolean type. Awesome. And so let's do the edge case where if the right-hand side equals 0, this is where we want to return false. And so left-hand side is referring to the, I guess, the relative position in the input parameters. And so if we scroll back up to the FizzBuzz, if any of the right-hand side is 0, we just immediately want to return false, because that would be doing n divided by 0, which is not something that we're interested in. All right, so now the main meat and potatoes. I had potatoes for dinner, so pardon the metaphor or analogy, but the potatoes were delicious if anyone was curious. So we actually want to do shorthand, left hand, modulo right hand side. So whatever the left hand is, hard, or is the remainder 0 or not? And so let's save, cargo run, and see the output of our labor. Ooh, cool. Okay. So we can see fizz is divisible by 3, buzz is divisible by 5, 15 is divisible by fizz by 5 and 3, so it's FizzBuzz. Okay. 100 is divisible by 5. Yeah, looks good to me. So this is our functionized FizzBuzz. That was pretty fun. I think now we can move on to, I'll briefly toggle back to the docs. We're going to move to associated functions and methods. So some functions are connected to a particular style. These come in two forms, associated functions and methods. So associated functions are functions that are defined on a type generally, while methods are associated functions that are called on a particular instance of a type. So I'm going to go right back into VS Code. Let's close this subproject up, and then let's create a new cargo project. I'm going to change back into the main subdirectory for today's work. So now we're going to do cargo, new. I'm going to call this associated functions and methods. That's a mouthful. And then let's change into that directory. Cool. Let's open up the main.rs and just get right into it. No time to waste. So we're going to just define a struct. We're going to call it point. We're going to just give it two input parameters, x of type float64, and then y also of type float64. Cool. And now we're going to do the implementation block so that all point associated functions and methods to go in there. So I'm actually going to add some white space in here to make it a little easier for me to think. So let's do the implementation keyword, the IMPL for point, curly brackets. So we're going to do a function definition, an associated function, because it's associated with the point type. And they don't need to be called within an instance, and they're just generally used like constructors. And so function origin, and it returns point type. With these values. Zero, zero, the origin. Okay. So our function is called origin. It returns a type point, and that value, the return value, is declared here. Simple enough. Next, let's define a function called new. This is another associated function. Takes two input parameters. We're going to give it an x, which is a type float64, a y, which is also type float64, and this function returns a point type, and that function body returns a point where x is x and y is y. Okay, and that is the entirety of our implementation block for the point struct. Next, let's move on and create another struct for ourselves. We're going to call this struct rectangle, and it's going to have two input parameters. The first one is called P1, and that's a type point. Ooh, very cool. Nested structs, let's go. The second one is called P2, also of type point. And then I expect some of you might already guess what we're going to do next. We're going to define an implementation block for our rectangle type, if I can spell that correctly. And so this is a method. Self is sugar, or the ampersand self is sugar for self colon ampersand self, where self is the type of the caller object. And in this case, self is rectangle. And so instead of me just blabbering ampersand self, I'm going to type a little, because I know many people are visual learners in addition to auditory learners. So we got function area ampersand, or a reference to self, and then it returns a type of float64. So let's just declare a variable binding. Let point x, ooh, accidentally clicked out of my window. It happens. Let x be x1, and then y1 equals self dot p1. So some like tricky little destructuring. And then we're going to do this again for the P2 using very similar syntax. Let me get that space in there so it's nice and tidy like the previous line. Y is Y2. Let me add a space here too to make it clean. Self.P2. We're good to go, and I forgot some semicolons because it happens. Okay. And so now let's get the absolute value, or let's do a little bit of arithmetic and use the absolute value method, which is a float64 type method that we can use at our leisure. So we've got x minus, or x1, if I can type it out, minus x2, and then we want to do times y1 minus y2, and then we're going to take the absolute value of that expression result. Sweet. And that'll be our area computation. Next, let's do another method. This one will be called perimeter. It'll also take reference to self as input, and it'll also return a type float64. So we're going to very similarly declare some variable bindings. So I'm going to copy paste it to save my fingers from inevitable carpal tunnel, or delay the inevitable carpal tunnel more appropriately. And so now we're going to do 2.0 times, so now this is going to be x1 minus x2. Let me add some spaces in there for readability. x2, the absolute value of that, so the magnitude, and then we want to do plus y1 minus y2, also the absolute value of that. There we go. Sweet. And now we're going to do our last method for rectangle. And that'll be translate. And this also, or this will now, instead of just a direct reference to self, we're going to do a mutable reference to self. And we'll also take an input parameter x of type float64 and an input parameter y of type float64. So self.p1.x plus equals x. Similarly, self.p2.x plus equals x. And for those that don't know, plus equals is same as, or x plus equals 1 is same as x equals x plus 1. Just so y'all know. Okay, so now 2 more. We're almost there. Self p1y plus equals y. Self.p2.y plus equals y. Lovely. And now we're on to our final struct declaration. And then we get to write our main function. We're getting there. But it's cool, we're building more complicated programs. So I dig it. So this structure will be called pair. And it owns resources. 2 heap allocated integers. Box on integer 32. So these are heap allocated. Okay, and so let's implement some methods for pair. So this first method will consume the resources of the caller object and self desugars to self colon uppercase self. So desugaring, I've never heard that. So function fn destroy self. Let pair first second equals self. Println macro destroying pair, and then we'll pass in the kind of string interpolator syntax, and then the values we want to interpolate, second or first and second. Okay, and that's it for pair and the pair implementation block. So let's now move on to the main function body. So I'm going to delete this println macro because we don't need it. Also delete some of this extra white space. So let's bind a variable called rectangle of type rectangle. And so we're going to invoke this associated function using double colon notation. So P1 is going to be point origin, and then P2 is going to be point new 3 4.0. Very cool. So methods are called using the dot operator. And so note that the first argument, ampersand self, is implicitly passed, i.e. rectangle dot perimeter parentheses is equivalent to uppercase rectangle colon perimeter and then a reference to rectangle. So let's do a couple println statements. Rectangle perimeter, and then pass in rectangle dot perimeter, and then println rectangle area, and this will also be the rectangle area. Semicolons. Okay, next we've got another variable binding. This one we're going to call square. It's also going to be immutable. It's also going to be a type of rectangle. So P1, again, we're using the associated function double colon notation. Point origin. P2 point new 1.0 1.0 semicolon. Missed the semicolon above too, it happens. Okay, now let's try to translate our square. It's mutable, so we should be able to tweak it. So square dot translate, and we want to pass some values here. So let's see if this works. So we'll do cargo run. Ooh, we got some errors. Cannot find Y in scope. Oh, okay, I missed an F on line 23. Did I? Or line 11. Line 11, there it is. Let's save that. Let's clear this just to make it easier to troubleshoot the bug. Okay, and now struct pairs never constructed. Fine, dead code warning, no biggie. Oh, so we're good to go. So rectangle perimeter is 14, rectangle area is 12. I like it. Okay, and our square translate method worked. Let's actually print out what happens to our square. Let's print out the dimensions of our square before and after translation, just because I'm curious to see if anything changes. Actually, let me do one thing at a time, not try to multitask like crazy. Okay, save. Rectangle 14. 12, and then square perimeter 4, 1. Okay, nothing changed just like crazy. What if we pass in a more wacky value set? Yeah, let's see what happens when we mutate or translate it using different numbers. Interesting. We get the same thing. Okay. It's like the translation is not persisting or something. I don't know. It's weird. All right. Let's just invoke our pair method and then move on to the next lesson because we got the gist. So we're doing box, associated method new, box, new, 2. Those are both integers. So we got our pair, and let's destroy our pair. Destruction. Voila. That was a whirlwind tour of associated functions and methods. On that note, let's call it today. And this will be a multi-parter just because there's plenty to learn about functions. So thank you again for hanging out with me today. Really appreciate your company and hope to see you next time. I'm Alex. This has been Code Along with Alex, and see you around the chain.